Balance the following chemical equations and classify them as either combination, decomposition, single replacement, or double replacement. Now, as we look at this problem, first thing I will point out is that when I printed this off, I had a typo on there that I have since fixed on the online version that you're actually using for homework. But rather than start over on these, I'm just going to make a quick edit. Also, if we start balancing elements that are not oxygen or hydrogen, we can start with Pb. Now, Pb stands for lead on the periodic table. It's not one that I asked you to memorize, but it is one that is good to know, and for balancing, we would treat it the same as we would calcium or sulfur or any other of the elements that I did ask you to memorize. So, in this case, we have one on each side, so they're balanced. Now, as I look at my carbons, I have 2 times 2, so I have 4 carbons on one side. I have 2 times 3 on the other. Now, some people may be going through and wondering, well, that's just the same acetate ion. Can I simply look at it that way, as I have 2 acetates on one side and 3 acetates on the other? And the short answer is, most of the time, you're okay. We will deal with some reactions where the acetate actually becomes a new species, not acetate on the product side. But if it's acetate on one side and acetate on the other, you can balance them as blocks or units within the reaction. So in this case, we have 2 acetates on one side, 3 on the other. To get to our least common multiple, we would need 6 acetates on both sides. If we were looking at this from a carbon standpoint, we had 4 and 6. We'd still be looking for 12 carbons. We'd end up with the same coefficients, either way of looking at it in this particular problem. If we look at our irons, we have 1 iron on this side, but this coefficient of 2 now makes 2 irons on the product side. A quick coefficient of 2 in front of the iron 3 chloride fixes that. Then if we look at the chlorides, the only element that we haven't, other than oxygen and hydrogen, that we haven't dealt with yet, we have 6 on the reactant side. So if we put a 3 in front of the last chemical, we would have 6 chlorines on the product side. Finally, we look at hydrogen. We have 9 on this side. 18. 3 times 3 times 2. We have 18 hydrogens on the reactant side. We have 2 times 3 times 3. 18 hydrogens on the product side. And lastly, oxygen would be 2 times 2 times 3. That would be 12. And then we have 2 times 3 times 2. Also 12 oxygens on the product side. We're now balanced. In terms of classification, we have 2 compounds reacting to form 2 different compounds. This is a double replacement. In the next problem, we have iron 3 oxide reacting with magnesium to form magnesium oxide, and pure iron. So if we look at balancing our irons, we have 2 on this side, only 1 on the product side. So I can put a 2 in front of that to balance our iron. We have 3 oxygens on the reactant side, only 1 on the product side. Seen at a glance that we had the same number of magnesium, so I'm going to skip those. But to get the oxygens to balance, I need a 3 in front of the magnesium oxide. But now, I'll also need a 3 in front of the pure magnesium to make sure everything balances nicely. In this reaction, we have a compound reacting with a pure element to form a different compound and a different pure element. This is a single replacement reaction. In the next problem, we have Hg2O, which would be mercurous oxide, reacting to form mercury metal, liquid mercury, and oxygen gas. So in this reaction, we have 2 mercuries on one side, only 1 on the other. If I put a coefficient of 2 in there, that would balance my mercuries. I look at my oxygens, I have 1 on the reactant side, 2 on the product side. So I need to double the mercurous oxide, or the mercury 1 oxide. However, when I do that, that has messed up my balancing of the mercury, and I need to change that coefficient to a 4 now, in order to have this fully balanced. Here we have a single compound breaking down into 2 or more simpler compounds or pure elements. This would be a decomposition. Lastly, we have carbon, such as what you would find in diamonds or pure coal. Reacting with oxygen, we're burning it to form carbon dioxide. We have 1 carbon on the reactant side, 1 carbon on the product side, 2 oxygens on both sides. This is already balanced. Now, sometimes it's a little unnerving if you look back through your problems and see something that has no marks on it. How do you know if it's complete? It's fine to go through and put 1s in those spots. Not necessary, but sometimes it's comforting to go back through and know that you actually did work the problem and hadn't skipped it for some reason. But whether you have blanks or 1s, either is considered equivalent to the other. Don't put zeros. 0 means that chemical doesn't exist in the reaction, and that would be incorrect. So in this one, we have 2 pure elements react to form a more complicated compound. This is a combination reaction.